In this video, we're going to go over page 3 of the ACT math test, and that's problems 16 through 23. Since that's 8 problems, I'd recommend you try to do these problems in about 8 minutes. You can either pause the video here and try all 8 problems for yourself, maybe either just give yourself 8 minutes to do them, or time yourself and just see how long it takes. Or throughout the video, I'll give you time on each problem to pause and try the problem for yourself before we go over it together. I do also have timestamps in the description, so feel free to skip around in this video if there's a specific problem you're looking for. Number 16 says, what value of x satisfies the equation -3 times quantity 4x minus 5 equals 2 times the quantity 1 minus 5x? So we just have to solve this equation, and the first thing I'm going to do is distribute these numbers, the -3 and the 2, into these sets of parentheses. So -3 times 4x is -12x, -3 times -5 is positive 15, equals, and then the other side is 2 times 1, so 2, and 2 times -5x is -10x. And so now we can combine like terms. I see we have an x term on both sides, so I want to get them on the same side, and I could either add 12 over to the right side, or I could add 10 over to the left side. I'm going to add the 12x because that will make it a positive amount of x's on the right, since 12 is bigger than 10. So we have 15 equals 2, and then -10 plus 12 is 2. So plus 2x. And then we can subtract the 2, and we get 13 equals 2x, and then divide both sides by 2. So we can see the answer is k. And of course, since this is just solving an equation, the ACT categorizes this problem as algebra. Number 17 says, in right triangle ABC shown below, the given lengths are in millimeters. What is the sine of A? So a lot of people have learned SOHCAHTOA, which is just a way to remember what side lengths match up with which trig function. S is for sine, C is cosine, T is tangent. And so sine is opposite over hypotenuse. So the sine of A is here. The sine of A would be the opposite side. So imagine you're like sitting in the corner of this triangle-shaped room, and you're looking at the opposite wall, right? So the opposite side is the 7, and then the hypotenuse, H, is always the side that's across from the right angle. So that's 7 over 9. Now, this is a trigonometry problem, but this is something that you learn in geometry. So ACT categorizes this as a geometry problem. Number 18 wants you to evaluate what this is. So it's 27 over 64 to the -2/3 power. So first of all, you could just type this directly into a calculator. Just make sure you type it in correctly. You'd want to do something like parentheses 27 divided by 64, parentheses, and then the little up caret for exponents. Now, the -2/3 all has to be part of the exponent, so I'm going to say -2 divided by 3. If you type it in exactly like that, it should give you the answer. Unfortunately, your calculator might spit out a decimal, so you can either try to change that decimal to a fraction if you know how to do that on your calculator, or you're going to have to do some of this by hand. And because this is an educational video, I'm going to teach you how to actually do this problem. So the negative exponent tells you that we should take this base, the fraction, 27 over 64, and flip it. So we're going to write it as 64 over 27, and now that's to the +2/3 power. So it's kind of like I did, air quotes, did the negative exponent, and that leaves me with this. Now the next thing to remember is when you have a fractional exponent, okay, I'm not worried about this right now, just the exponent itself is a fraction, the bottom number can be turned into a root. So I could rewrite this as 64 over 27, but then I'm going to take the third root of that, and then the 2 stays up here in the exponent, like it's squared. And actually, it doesn't matter if you write the 2 on the outside of the radical or on the inside. I'm just going to write it out here for now. So then I need to do the third root of this fraction. And that looks scary, but it's just what is the third root of 64, which if you took some time, you could figure that out even just by hand. What times itself 3 times is 64. I mean, 8 times 8 is 64, so that doesn't quite work. It must be smaller than that. And of course, I'm walking you through this doing this by hand. But again, you could just type this into a calculator. But the third root of 64 is 4. 4 times 4 is 16, times 4 again is 64. And then the third root of 27 is 3. So all of this stuff simplifies to 4/3, and then we have to take that fraction and still square it. So again, we're going to square the top and square the bottom, just like I took the third root of the top and the third root of the bottom. So 4 squared is 16, and 3 squared is 9. So 16 over 9. So the answer is J. And this problem falls under the category number and quantity. Number 19 says, Lodo begins at his back door and walks 8 yards east, 6 yards north, 12 yards east, and 5 yards north to the barn door. About how many yards less would he walk if he could walk directly from the back door to the barn door? Now, when I do a problem like this, I would like to try to draw it out as I'm reading through it. So he begins at his back door. He goes 8 yards east, so I'll write 8, and then 6 yards north. And this isn't really to scale, it's just a little diagram. And then 12 yards east, so it's a little bit bigger, and then 5 yards north. So all in all, how far did he walk? If we add all this up, let's see, 8 and 12 is 20, plus 6 is 26, plus 5 is 31. So he walked 31 yards total. But how far would he have walked if he just went from point A straight to point B? Well, instead of taking all these turns like this, what if he just went straight east all the way? So 8 plus 12, that's 20 yards east. And then 6 plus 5 is 11. So we can use the Pythagorean theorem now because we have a right triangle, and we can do 20 squared plus 11 squared, right? Because the Pythagorean theorem is a squared plus b squared equals c squared. And this always has to be the hypotenuse. So we'll say 20 squared plus 11 squared equals, and that will tell us what we get for c squared. So this is 400 plus 121, so that would be 521, and that's c squared, but then we have to take the square root of that to figure out what c is. So if you type the square root of 521 into a calculator, you get about 22.8, and obviously there's no decimal answers here, so we're going to be rounding, and it does say about how many yards less. So we figured out that this hypotenuse length is 22.8, but we know that he already walked 31 miles. So if we do 31 minus 22.8, you get 8.2, which is pretty close to 8, so the answer must be A. And this is categorized under geometry and modeling. Number 20 says, for a given set of data, the standard score z corresponding to the raw score x is given by z equals x minus mu over sigma, where mu is the mean of the set and sigma is the standard deviation. If, for a set of scores, mu equals 78, sigma equals 6, which of the following is the raw score x corresponding to z equals 2? All right, so before we actually calculate anything here, let me just point out that this is an incredibly wordy problem, and it's absolutely not necessary. You could probably skip reading most of this. They're explaining a lot of like stats terms here. Mu is mean, sigma is standard deviation. You don't need to understand what any of those things are to do this problem. It's just giving you a bunch of values for you to plug into this formula, and then you have to figure out what x would be. So they said z is 2, so I'll plug in 2 where z was, and then x, I don't know what x is, that's what I'm going to be solving for. They told me mu is 78, so minus 78 over 6, because sigma is 6. Now I just have to solve this for x. So the first thing I want to do is get rid of the 6, get that out of the denominator, so I'm going to multiply both sides by 6. 6 times 2 is 12, and then we have x minus 78. So I'll just have to add 78 to both sides. And we get 90. So the answer is F. And this, of course, falls under statistics as well as modeling. All right, number 21 says, in the figure below, A, B, C, and D lie on the circle centered at O. Which of the following does not appear in the figure? Again, we really didn't need to read any of this. They gave us a diagram, and then they're asking a pretty clear question. And it really has nothing to do with the letter names or anything like that. So an acute triangle is a triangle that has an acute angle in it. An equilateral triangle has 60-degree angles, so this is 60 degrees. And since these two side lengths are both the radius of the circle, that means they're the same. So if those two side lengths are the same, these two angles are the same. That's another thing we learn in geometry. And so I can actually tell that this is an equilateral triangle because there's 180 degrees total in a triangle. If I take out the 60 that they told me about, that leaves me with 120 degrees. And if I cut that in half, right, because both of these are equal angles or equal measurements, that means that these are all 60 degrees. So we do have an equilateral triangle. We also have an acute triangle because this is a triangle with an acute angle in it. What about an isosceles triangle? An isosceles triangle just means a triangle with two of the same side lengths that are the same. And we can see that here, and we can even see it here too. A right triangle just has to have a right angle in it, and we see that here at angle O, DOC. And so the only one left is scalene. So the answer is E. A scalene triangle just means it doesn't have any of the same angles or any of the same side lengths, and we don't see that anywhere in this diagram. Number 21 actually just falls under integrating essential skills. Number 22 says, what is the slope of a line in the standard xy coordinate plane that is parallel to x plus 5y equals 9? So if we're looking for a parallel line, that means it's going to have the same slope. So I just need to figure out what is the slope of this line. And to do that, I'd really like to see it written in slope-intercept form, like y equals mx plus b. So we're going to do some rewriting. The first thing I'm going to do is, because I want to get the y alone, I'm going to get rid of the x first. So we'll subtract x from both sides. So we have 5y equals negative x plus 9. And I'm just writing it that way so that the x term is first, so that we're looking at the slope term. And then we'll have to divide both sides by 5. So y equals, and then negative x over 5 could be rewritten as like negative 1/5 x, and then 9 over 5, we'll just rewrite that as 9 over 5, 9/5. So the slope then is this number right in front of x, so negative 1/5, so the answer is G. And 22 falls under the geometry category. Number 23 says, given y equals x over x minus 1, and x is greater than 1, which of the following is a possible value for y? Now there's a couple ways you could do this problem. You could approach it algebraically, and I'm just going to go through that quickly. So one way I thought of doing this problem is to take all of these values that they give us, which are maybe possible values of y, and then plug them in to see if we get an x value that's greater than 1. The problem with that right now is we would be plugging y in over here, and then we'd have to do a bunch of math to solve for what x is. So if we want, we could rewrite this equation so it's more in terms of y. So the first thing I'm going to do is multiply both sides by x minus 1. So on the left we have y times x minus 1. On the right side we just have the x left over. Then we can distribute the y in, so we get xy minus y equals x. And keep in mind that the whole point is we're trying to get all of the x's together into just one spot. So what I'm going to do next is subtract x so that we have like terms. So we have xy minus x, still minus y equals 0. And then we'll add y over to the right side, because we want to get rid of that if we can. So xy minus x equals y. And now we can actually factor an x out of both of these terms. This is called greatest common factor. So if we take x out, now it's just in one spot, and we're left with y from the first term. And then if I take negative x and factor an x out or divide x out, I'll be left with minus 1 equals y. So now if I divide both sides by y minus 1, I get x equals y over y minus 1. And this gives me something where I could plug in a bunch of y values and see what I get for x. For instance, I could plug in, let's do an easy one just for an example. Let's plug in 0. So 0 over 0 minus 1 is 0 over negative 1, which is 0. So is that possible? Because they said x is greater than 1, and this is saying x is 0, that can't be possible. So this can't be an answer. And you could do that with all 5 of these possibilities and see which one gives you something that actually satisfies this equation. Another way of doing this, which is a lot easier, but requires access to a graphing calculator, is just to graph this. So the equation y equals x over x minus 1 looks like this. This is called a rational graph. And if we look at where x is greater than 1, that's basically just to the right side. And then it's asking, like, what is a possible value of y? So looking at the graph, you can see that the y value never gets lower than 1. So obviously it can't be a, b, we already saw it couldn't be c, d is still less than 1, and so the answer must be e.